Find the dimensions of a rectangle that has a perimeter of 52 inches and a maximum area. You know that the perimeter of a rectangle is equal to 2 times the length plus 2 times the width. Set 52 equal to P. You know that the area of a rectangle is length times width. Solve for L in the perimeter equation to substitute it into the area equation. Subtract 2W from both sides. Divide both sides by 2. You find that L is equal to 26 minus W. Substitute 26 minus W in for L. Simplify 26 minus W times W. You find that the area is equal to 26W minus W squared. Use the method of guess and check to find a maximum area. Test the W values 12, 12 and 5/10, 13, 13 and 5/10, and 14. Substitute 12 in for W in the area equation. Simplify 26 times 12 and 12 squared. Simplify 312 minus 144. You find that the area is 168. Substitute 12 and 5/10 in for W in the area equation. Simplify 26 times 12 and 5/10 and 12 and 5/10 squared. Simplify 325 minus 156 and 25/100. You find that the area is 168 and 75/100. Substitute 13 in for W in the area equation. Simplify 26 times 13 and 13 squared. Simplify 338 minus 69. You find that the area is 169. Substitute 13 and 5/10 in for W in the area equation. Simplify 26 times 13 and 5/10 and 13 and 5/10 squared. Simplify 351 minus 182 and 25/100. You find that the area is equal to 168 and 75/100. Substitute 14 in for W in the area equation. Simplify 26 times 14 and 14 squared. Simplify 364 minus 196. You find that the area is 168. Because 13 produced the largest area, you know that the width of the rectangle is 13. Substitute 13 in for W in the length equation. Simplify 26 minus 13. You find that the length is equal to 13. You can say that the limit of 26W minus W squared as W approaches 13 is 169. The dimensions of the rectangle are 13 by 13 inches. Use a table to estimate numerically the limit. The limit of 3 minus 2x as x approaches 3. Because you want to know the limit as x approaches 3, test numbers near 3. Test the numbers 2 and 9/10, 2 and 99/100, 2 and 999 thousandths, 3, 3 and 1,000th, 3 and 100th, and 3 and 1/10. Substitute 2 and 9/10 into the equation 3 minus 2x. Simplify negative 2 times 2 and 9/10. Simplify 3 minus 5 and 8/10. You find that f of x is equal to negative 2 and 8/10. Substitute 2 and 99/100 into the equation 3 minus 2x. Simplify negative 2 times 2 and 99/100. Simplify 3 minus 5 and 98/100. You find that f of x is equal to negative 2 and 98 hundredths. Substitute 2 and 99 hundredths into the equation 3 minus 2x. Simplify negative 2 times 2 and 99 hundredths. Simplify 3 minus 5 and 98 hundredths. You find that f of x is equal to negative 2 and 98 hundredths. Substitute 2 and 999 thousandths into 3 minus 2x. Simplify negative 2 times 2 and 999 thousandths. Simplify 3 minus 5 and 998 thousandths. You find that f of x is equal to negative 2 and 998 thousandths. Substitute 3 and 1,000th into 3 minus 2x. Simplify negative 2 times 3 and 1,000th. Simplify 3 minus 6 and 2 thousandths. You find that f of x is equal to negative 3 and 2 thousandths. Substitute 3 and 100th into 3 minus 2x. Simplify negative 2 times 3 and 100th. Simplify 3 minus 6 and 200ths. You find that f of x is equal to negative 3 and 200ths. Substitute 3 and 1/10 into 3 minus 2x. Simplify negative 2 times 3 and 1/10. Simplify 3 minus 6 and 2/10. You find that f of x is equal to negative 3 and 2/10. You find as x gets closer to 3, f of x gets closer to negative 3. So you find that the limit of 3 minus 2x as x approaches 3 is negative 3. Use the table to estimate numerically the limit of x minus 1 divided by x squared plus 3x minus 4 as x approaches 1. To find the limit as x approaches 1, substitute x values in that approach 1. Substitute in 9/10ths, 99 hundredths, 999 thousandths, 1, 1 and 1,000th, 1 and 100th, and 1 and 1/10. Simplify the fraction x minus 1 divided by x squared plus 3x minus 4 by factoring the denominator. Divide out common factors. Substitute 9/10ths into 1 divided by x plus 4. Simplify 9/10ths plus 4. Simplify 1 divided by 4 and 9/10ths. You find that f of x is approximately equal to 204,082 millionths. Substitute 99 hundredths into 1 divided by x plus 4. Simplify 99 hundredths plus 4. Simplify 1 divided by 4 and 99 hundredths. You find that f of x is approximately equal to 200,401 millionths. Substitute 999 thousandths into 1 divided by x plus 4. Simplify 999 thousandths plus 4. Simplify 1 divided by 4 and 999 thousandths. You find that f of x is approximately equal to 200,040 millionths. Substitute 1 and 1,000th into 1 divided by x plus 4. Simplify 1 and 1,000th plus 4. Simplify 1 divided by 5 and 1,000th. You find that f of x is approximately equal to 199,960 millionths. Substitute 1 and 100th into 1 divided by x plus 4. Simplify 1 and 100th plus 4. Simplify 1 divided by 5 and 100th. You find that f of x is approximately equal to 199,601 millionths. Substitute 1 and 1/10 into 1 divided by x plus 4. Simplify 1 and 1/10 plus 4. Simplify 1 divided by 5 and 1/10. You find that f of x is approximately equal to 196,078 millionths. As x approaches 1, f of x approaches 2/10ths. So you find that the limit of x minus 1 divided by x squared plus 3x minus 4 as x approaches 1 is equal to 2/10ths. Estimate the limit. The limit of x cubed minus 2x squared plus 3x minus 6 divided by x minus 2 as x approaches 2. To solve numerically, create a table of values. Because you want to know what the limit as x approaches 2 is, choose values of x approaching 2. Choose 1 and 9/10, 1 and 99/100ths, 1 and 999 thousandths, 2 and 1,000th, 2 and 100th, and 2 and 1/10. Simplify the fraction by factoring the numerator. Cancel out common factors. You find that x cubed minus 2x squared plus 3x minus 6 divided by x minus 2 is equivalent to x squared plus 3. Substitute 1 and 9/10 into x squared plus 3. Simplify 1 and 9/10 squared. Simplify 3 and 61/100ths plus 3. You find that f of x is 6 and 61/100ths. Substitute 1 and 99/100ths into x squared plus 3. Simplify 1 and 99/100ths squared. Simplify 3 and 9,601/10,000ths plus 3. You find that f of x is 6 and 9,601/10,000ths. Substitute 1 and 999 thousandths into x squared plus 3. Simplify 1 and 999 thousandths squared. Simplify 3 and 996,001 millionths plus 3. You find that f of x is 6 and 996,001 millionths. Substitute 2 and 1,000th into x squared plus 3. Simplify 2 and 1,000th squared. Simplify 4 and 4,001 millionths plus 3. You find that f of x is 7 and 4,001 millionths. Substitute 2 and 100th into x squared plus 3. Simplify 2 and 100th squared. Simplify 4 and 401/10,000ths plus 3. You find that f of x is 7 and 401/10,000ths. Substitute 2 and 1/10 into x squared plus 3. Simplify 2 and 1/10 squared. Simplify 4 and 41/100ths plus 3. You find that f of x is 7 and 41/100ths. As x approaches 2, f of x approaches 7. To use the graphical solution, use the graphing utility to graph x cubed minus 2x squared plus 3x minus 6 divided by x minus 2. Use the trace feature to determine that as x gets closer to 2, y gets closer to 7. Notice that there is no value for y when x equals 2, and that there is a hole or break in the graph at x equals 2. Therefore, the limit of x cubed minus 2x squared plus 3x minus 6 divided by x minus 2 as x approaches 2 is 7. Find the limit of f of x as x approaches 2, where f of x is defined as f of x is equal to negative 3 when x is not equal to 2, and 0 when x is equal to 2. Because f of x equals negative 3 for all other values other than x equals 2, and because the value of f of 2 is immaterial, it follows that the limit is negative 3. Show that the limit does not exist. The limit of 2 times the absolute value of x minus 1 divided by x minus 1 as x approaches 1. Consider the graph of f of x equals 2 times the absolute value of x minus 1 divided by x minus 1. You can see that for x values greater than 1, f of x is equal to 2, and for x values less than 1, f of x is equal to negative 2. This means that no matter how close x gets to 1, there will be both positive and negative x values that yield f equals 2 and f equals negative 2. This implies that the limit does not exist. Discuss the existence of the limit. The limit of negative 1 divided by x squared as x approaches 0. Let f of x equal negative 1 divided by x squared. Graph f of x. Note that as x approaches 0 from either the left or the right, f of x decreases without bound. This means by choosing x close enough to 0, you can force f of x to be as small as you want. Because f of x is not approaching a unique real number L as x approaches 0, the limit does not exist. Discuss the existence of a limit. The limit of the cosine of 1 divided by x minus 1 as x approaches 1. Let f of x equal the cosine of 1 divided by x minus 1. Graph f of x. You can see that as x approaches 1, f of x oscillates between negative 1 and 1. So the limit does not exist, because no matter how close you are to 1, it is possible to choose values of x such that f of x is equal to 1 and negative 1. Find each limit. Part A. The limit of 1/4 as x approaches 3. Substitute 3 in for x in 1/4 and simplify. We found the limit of 1/4 as x approaches 3 to equal 1/4. Part B. The limit of x cubed as x approaches 3. Use property 5. Substitute 3 in for x in x cubed. Simplify 3 cubed. We find that the limit of x cubed as x approaches 3 is equal to 27. Part C. The limit of cosine of x divided by x as x approaches pi. Use property 4. Substitute pi in for x in the cosine of x divided by x. Simplify the cosine of pi. Simplify negative 1 divided by pi. You find that the limit of cosine of x divided by x as x approaches pi is equal to negative 1 divided by pi. Find each limit. Part A. The limit of x squared minus 3x plus 7 as x approaches 3. Substitute 3 in for x. Simplify 3 squared and negative 3 times 3. Simplify 9 minus 9 plus 7. You find that the limit of x squared minus 3x plus 7 as x approaches 3 is equal to 7. Part B. The limit of x squared minus 3x plus 7 divided by x as x approaches 3. Substitute 3 in for x. Simplify 3 squared and negative 3 times 3. Simplify 9 minus 9 plus 7. You find that the limit of x squared minus 3x plus 7 divided by x as x approaches 3 is equal to 7/3. Find the limit. The limit of x squared minus 7x plus 12 divided by x minus 4 as x approaches 4. Factor x squared minus 7x plus 12. Divide out common factors and simplify. Substitute 4 in for x. Simplify 4 minus 3. You find that the limit of x squared minus 7x plus 12 divided by x minus 4 as x approaches 4 is equal to 1. Find the limit. The limit of x minus 7 divided by x cubed minus 7x squared plus 7x minus 49 as x approaches 7. Factor x cubed minus 7x squared plus 7x minus 49. Divide out common factors. Substitute 7 in for x. Simplify 7 squared. Simplify 49 plus 7. You find that the limit of x minus 7 divided by x cubed minus 7x squared plus 7x minus 49 as x approaches 7 is equal to 1 divided by 56. Find the limit. The limit of 1 minus the square root of 1 minus x divided by x as x approaches 0. Rationalize the numerator by multiplying the numerator and denominator by its conjugate. Simplify 1 minus the quantity 1 minus x. Divide out common factors. Substitute 0 in for x. Simplify 1 minus 0. Simplify the square root of 1. Simplify 1 plus 1. You find the limit of 1 minus the square root of 1 minus x divided by x as x approaches 0 to equal 1/2. Approximate the limit. The limit of e to the x minus 1 divided by x as x approaches 0. Use the table feature of a graphing utility to create a table that shows the values of f for x starting at -3,000ths and has a step of 1,000th. Because 0 is halfway between -1,000th and 1,000th, use the average of the values of f at these two x coordinates to estimate the limit. Simplify 1 and 5,000ths plus 995 thousandths. Simplify 2 divided by 2. You find that the limit of e to the x minus 1 divided by x as x approaches 0 is 1. Approximate the limit. The limit of 1 minus the cosine of x divided by x as x approaches 0. To approximate the limit, begin by using a graphing utility to graph f of x equals 1 minus the cosine of x divided by x. Then, use the zoom and trace features of the graphing utility to choose a point on each side of 0. Approximate the limit as the average of the y-coordinates of these 2 points. Simplify the numerator. Simplify the fraction. You can approximate that the limit of 1 minus the cosine of x divided by x as x approaches 0 is 0. Find the limit as x approaches 3 from the left and the limit as x approaches 3 from the right, for f of x equals the absolute value of x minus 3 divided by x minus 3. From the graph, you can see that f of x equals -1 for all values x less than 3, so the limit from the left is -1. Because f of x equals 1 for all values of x greater than 3, the limit from the right is 1. Find the limit of f of x as x approaches -1. F of x is equal to the set of -x squared minus 3x when x is less than -1, and x plus 3 when x is greater than -1. Because this equation is a set of equations, you have two one-sided limits. Solve each one-sided limit. The limit of -x squared minus 3x as x approaches -1 from the negative side. Substitute -1 in for x. Simplify -1 squared and -3 times -1. Simplify -1 plus 3. You find that the limit of -x squared minus 3x as x approaches -1 is 2. Solve the limit of x plus 3 as x approaches -1 from the positive side. Substitute -1 in for x. Simplify -1 plus 3. You find that the limit of x plus 3 as x approaches -1 is also 2. Because both one-sided limits equals 2, the limit of f of x is equal to 2. In example 8, show that the limit of f of x as x approaches 1 does not exist. F of x is equal to the set 24 when 0 is less than x is less than or equal to 1, 28 when 1 is less than x is less than or equal to 2, and 32 when 2 is less than x is less than or equal to 3. Because the question asks about x approaching 1, focus on the first two equations. Set up and solve two one-sided limits. The first limit is the limit of f of x when x approaches 1 from the negative side is equal to 24. The second one-sided limit is the limit of f of x when x approaches 1 from the positive side, which is equal to 28. Because both one-sided limits are different, the limit of f of x does not exist. For the function f of x is equal to 4x minus x squared, Find the limit of f of 2 plus h minus f of 2 divided by h as h approaches 0. Substitute f of 2 plus h and f of 2 into the equation. Simplify the numerator. Simplify negative 1 times the quantity 4 plus 4h plus h squared. Simplify the numerator. Simplify the fraction. Substitute 0 in for h. The limit of f of 2 plus h minus f of 2 divided by h as h approaches 0 is equal to 0. Find the limit. The limit of 1 minus the cosine of x divided by x as x approaches 0. Use the squeeze theorem. Using the squeeze theorem, you can determine that the tangent of x divided by 2 is greater than or equal to x divided by 2 is greater than or equal to sine x divided by 2. Multiply all parts of the inequality by 2 divided by 1 minus the cosine of x. Invert the inequality and remember to flip the inequality signs. Separate the fraction 1 minus the cosine of x divided by the tangent of x and 1 minus the cosine of x divided by the sine of x. Invert the inequality and remember to flip the inequality signs. Take the limit of the tangent of x minus the tangent of x divided by the cosine of x and the sine of x minus the sine of x divided by the cosine of x as x approaches 0. Invert the inequality. Remember to flip the inequality signs. Because 0 is less than or equal to 1 minus the cosine of x divided by x is less than 0, that means that the limit of 1 minus the cosine of x divided by x as x approaches 0 is 0. Check this by graphing 1 minus the cosine of x divided by x. You can see that the function approaches 0. Use the figure 1215 to approximate the slope of the graph of f of x equals x squared at the point 2, 4. Find the point 2, 4 on the graph and draw a tangent line. The slope of a line is the change in y over the change in x. You can see that there's an approximate change in y of 4 and an approximate change in x of 1. Substitute 4 in for change in y and 1 in for change in x. Simplify 4 divided by 1. The approximate slope of the graph at the point 2, 4 is 4. In example 2, approximate the slope of the graph at the point 4, 65 and give a physical interpretation of the result. Find the point 4, 65 and draw a tangent line. The slope of a line is the change in y over the change in x. You can see that there's an approximate change in y of 10 and an approximate change in x of 1. Substitute 10 in for change in y and 1 in for change in x. Simplify 10 divided by 1. You find that the slope is 10, which is 10 degrees per month. This means that you can expect the normal monthly temperature in May to be about 10 degrees higher than the normal temperature in April. Find the slope of the graph of g of x is equal to x squared minus 2x at the point 3, 3. The slope of the secant line is f of x plus h minus f of x divided by h. Substitute g of x plus h, which is g of 3 plus h, and g of 3 into the equation. Simplify g of 3 plus h and g of 3. Simplify 3 plus h, negative 2 times the quantity 3 plus h, 3 squared, and negative 2 times 3. Simplify the numerator. Simplify the fraction. You find m secant is h plus 4. Take the limit of m secant as h approaches 0 to find the slope. Substitute 0 in for h. You found that the slope at the point 3, 3 is 4. Find the slope of f of x is equal to negative 3x plus 4. To find the slope of the equation, use the formula the slope is equal to the limit of f of x plus h minus f of x divided by h as h approaches 0. Substitute in f of x plus h and f of x. Simplify negative 3 times the quantity x plus h and negative 1 times the quantity negative 3x plus 4. Simplify the numerator. Simplify the fraction. Take the limit as h approaches 0. You find that the slope of f of x is negative 3. Find a formula for the slope of the graph of f of x equals 2x squared minus 3. What is the slope at the points negative 3, 15, and 2, 5? Use the formula the slope is equal to the limit of f of x plus h minus f of x divided by h as h approaches 0. Substitute in f of x plus h and f of x. Simplify x plus h quantity squared and negative 1 times the quantity 2x squared minus 3. Simplify 2 times the quantity x squared plus 2xh plus h squared. Simplify the numerator. Simplify the fraction. Take the limit of 4x plus 2h as h approaches 0. You find that the slope is equal to 4x. To find the slope at negative 3, 15, substitute negative 3 into the slope equation. Simplify 4 times negative 3. You find the slope at negative 3, 15 is negative 12. To find the slope at 2, 5, substitute 2 into the slope equation. Simplify 4 times 2. You find that the slope at 2, 5 is 8. Find the derivative of f of x equals x cubed plus 2x. Use the formula the derivative equals the limit of f of x plus h minus f of x divided by h as h approaches 0. Substitute in f of x plus h and f of x. Simplify x plus h quantity cubed, 2 times the quantity x plus h, and negative 1 times the quantity x cubed plus 2x. Simplify the numerator. Simplify the fraction. Take the limit as h approaches 0. You find that the derivative is 3x squared plus 2. Find the derivative of f of x equals the square root of x minus 1. Then find the slopes of the graph of f at the points 2, 1, and 10, 3. To find the derivative, use the formula the derivative is equal to the limit of f of x plus h minus f of x divided by h as h approaches 0. Substitute in f of x plus h and f of x. Rationalize the numerator by multiplying the numerator and denominator by its conjugate. Simplify the numerator. Simplify the fraction. Simplify the limit as h approaches 0. Simplify the denominator. You find that the derivative is 1 divided by 2 times the square root of x minus 1, which is also the slope. To find the slope at 2, 1, substitute 2 into the slope equation. Simplify 2 minus 1. Simplify the square root of 1. You find that the slope at 2, 1 is 1/2. To find the slope at 10, 3, substitute 10 into the slope equation. Simplify 10 minus 1. Simplify the square root of 9. Simplify 2 times 3. You find that the slope at 10, 3 is 1/6. Find the limit. The limit of 2 divided by x squared as x approaches infinity. To find the limit of 2 divided by x squared as x approaches infinity, simplify it to 2 times the limit of 1 divided by x squared as x approaches infinity. As x squared approaches infinity, 1 divided by x squared approaches 0. So the limit of 2 divided by x squared as x approaches infinity is 0. Find the limit as x approaches infinity, if possible, for each function. Part A. F of x is equal to 2x divided by 1 minus x squared. Divide the numerator and denominator by the highest power of x, which is x squared. You know that as x approaches infinity, 1 divided by x approaches 0, and as x approaches infinity, 1 divided by x squared approaches 0. Substitute 0 in for 1 divided by x and 1 divided by x squared. Simplify 2 times 0 and 0 minus 1. Simplify 0 divided by negative 1. You find that the limit of f of x is equal to 0. Part B. F of x is equal to 2x divided by 1 minus x. Divide the numerator and denominator by the highest power of x, which is x. You know that as x approaches infinity, 1 divided by x approaches 0. Substitute 0 in for 1 divided by x. Simplify 0 minus 1. Simplify 2 divided by negative 1. You find that the limit of f of x is negative 2. Part C. F of x is equal to 2x squared divided by 1 minus x. Divide the numerator and denominator by the highest power of x, which is x squared. You know that as x approaches infinity, 1 divided by x squared approaches 0, and as x approaches infinity, 1 divided by x approaches 0. Substitute 0 in for 1 divided by x squared and 1 divided by x. The limit of f of x does not exist because you cannot divide by 0. You are manufacturing greeting cards that cost 75 cents per card to produce. Your initial investment is $5,000, which implies that the total cost C of producing X cards is given by C is equal to 75 hundredths X plus 5,000. The average cost C bar per card is given by C bar is equal to C divided by X is equal to 75 hundredths X plus 5,000 divided by X. Find the average cost per card when A, X equals 1,000, B, X equals 10,000, and C, x equals 100,000. D. What is the limit of C bar as x approaches infinity? Part A. To find the cost per card when x equals 1,000, substitute 1,000 into the C bar equation. Simplify 75 hundredths times 1,000. Simplify 750 plus 5,000. Simplify 5,750 divided by 1,000. You find that the average cost per card when x equals 1,000 is $5.75. Part B. To find the average cost per card when x equals 10,000, substitute 10,000 into the C bar equation. Simplify 75 hundredths times 10,000. Simplify 7,500 plus 5,000. Simplify 12,500 divided by 10,000. You find that the average cost per card when x equals 10,000 is $1.25. Part C. To find the cost per card when x equals 100,000, substitute 100,000 into the C bar equation. Simplify 75 hundredths times 100,000. Simplify 75,000 plus 5,000. Simplify 80,000 divided by 100,000. You find that the average cost per card is 80 cents. Part D. Set up the limit of C bar as x approaches infinity. Divide the numerator and denominator by the highest power of x, which is x. You know that as x approaches infinity, 1 divided by x approaches 0. Substitute 0 in for 1 divided by x. Simplify 75 hundredths plus 0 divided by 1. The limit of C bar as x approaches infinity is 75 cents. Find the limit of each sequence. Assume that n begins with 1. Part A. A sub n is equal to n plus 2 divided by 2n minus 1. Set up the limit of a sub n as n approaches infinity. Divide the numerator and denominator by the highest power of n, which is n. You know that as n approaches infinity, 1 divided by n approaches 0. Substitute 0 in for 1 divided by n. You find that the limit of a sub n is 1/2. Part B. A sub n equals n cubed plus 2 divided by 3n cubed. Set up the limit of a sub n as n approaches infinity. Divide the numerator and denominator by the highest power of n, which is n cubed. You know that as n approaches infinity, 1 divided by n cubed approaches 0. Substitute 0 in for 1 divided by n cubed. You find that the limit of a sub n is 1/3. Part C. A sub n is equal to n plus 2 divided by 3n squared. Set up the limit of a sub n as n approaches infinity. Divide the numerator and denominator by the highest power of n, which is n squared. You know that as n approaches infinity, 1 divided by n approaches 0, and as n approaches infinity, 1 divided by n squared approaches 0. Substitute 0 in for 1 divided by n and 1 divided by n squared. Simplify 0 divided by 3. You find that the limit of a sub n is 0. Find the limit of each sequence whose nth term is given. Part A. A sub n is equal to 5 divided by n cubed times the quantity n plus 1 times n minus 1 times 2n divided by 7. Distribute 5 divided by n cubed into the quantity. Simplify the fraction. Simplify 5 times 2 and n plus 1 times n minus 1. Simplify 10 times the quantity n squared minus 1. Set up the limit of a sub n as n approaches infinity. From this form, you can see that the degree of the numerator is equal to the degree of the denominator, so the limit of the sequence is the ratio of the coefficients of the highest powered terms. The limit of a sub n is 10/7. Part B. A sub n is equal to 2 divided by n times the quantity n minus 2 divided by n times the quantity n times n minus 1 divided by 4. Distribute negative 2 divided by n to the quantity n times n minus 1 divided by 4. Simplify the fraction 2n times the quantity n minus 1 divided by 4n. Distribute 2 divided by n to the quantity n minus n minus 1 divided by 2 and simplify. Set up the limit of a sub n as n approaches infinity. Separate the limit of 2 minus n minus 1 divided by n into the limit of 2 minus the limit of n minus 1 divided by n. From this form, you can see that the degree of the numerators is equal to the degree of the denominators. So the limit of the sequence is the ratio of the coefficients of the highest powered terms. The limit of 2 is 2, and the limit of n minus 1 divided by n is 1. Simplify 2 minus 1. You find the limit of a sub n is 1. Evaluate the summation. The sum from I equals 1 to I equals 10 of I squared. Use the third summation formula. Substitute 10 in for n. Simplify 10 plus 1 and 2 times 10. Simplify 20 plus 1. Simplify 10 times 11 times 21 divided by 6. You find that the sum from I equals 1 to 10 of I squared is 385. Evaluate the summation S equals the sum from I equals 1 to n of 3i plus 2 divided by n squared, for n equals 10, 100, 1000, and 10,000. Use the first summation formula to bring 1 divided by n squared to the front of the summation. Use the second, fifth, and sixth summation formulas to take the sum from I equals 1 to n of 3i plus 2. Multiply 1 divided by n squared to the quantity 3n times the quantity n plus 1 divided by 2 plus 2n, and simplify. Combine the fractions by multiplying the second fraction by 2 over 2. To find the sum when n equals 10, substitute 10 into 3 times the quantity n plus 1 plus 4 divided by 2n. Simplify 10 plus 1 and 2 times 10. Simplify 3 times 11 plus 4. The sum when n equals 10 is 37/20ths, or 1 and 85/100ths. To find the sum when n equals 100, substitute 100 into 3 times the quantity n plus 1 plus 4 divided by 2n. Simplify 100 plus 1 and 2 times 100. Simplify 3 times 101 plus 4 divided by 200. You find the sum when n equals 100 is 307 divided by 200, or 1 and 535 thousandths. To find the sum when n equals 1000, substitute 1000 into 3 times the quantity n plus 1 plus 4 divided by 2n. Simplify 1000 plus 1 and 2 times 1000. Simplify 3 times 1001 plus 4 divided by 2000. You find that the sum when n equals 1000 is 3007 divided by 2000, or 1 and 5035 ten-thousandths. To find the sum when n equals 10,000, substitute 10,000 into 3 times the quantity n plus 1 plus 4 divided by 2n. Simplify 10,000 plus 1 and 2 times 10,000. Simplify 3 times 10,001 plus 4 divided by 20,000. You find that the sum when n equals 10,000 is 30,007 divided by 20,000, or 1 and 50,035 hundred-thousandths. Find the limit of s of n as n approaches infinity. S of n is equal to the sum of I equals 1 to n of the quantity 2 divided by n plus I divided by n squared times 1 divided by n. Simplify the quantity 2 divided by n plus I divided by n squared times 1 divided by n. Use the first summation formula to bring 1 divided by n squared to the front of the summation. Use the second, fifth, and sixth summation formulas to simplify the sum from I equals 1 to n of 2 plus I divided by n. Simplify 1 divided by n squared times the quantity 2n plus n times n plus 1 divided by 2n, and simplify. Set up the limit of s of n as n approaches infinity. You know that as n goes to infinity, 1 divided by n goes to 0, and as n goes to infinity, 1 divided by n squared goes to 0. Substitute 0 in for 1 divided by n and 1 divided by n squared. You find that the limit of s of n is equal to 0. Use the four rectangles in figure 1222 to approximate the area of the region bounded by the graph of f of x equals x plus 1, the x-axis, and the lines x equals 0 and x equals 2. Because the length of the interval along the x-axis is 2 and there are four rectangles, the width of each rectangle is 1/2. To obtain the height of each rectangle, evaluate f at the right endpoint of each interval. The four intervals are as follows. Know that the right endpoint of each interval is 1/2 I, for I equals 1, 2, 3, and 4. The sum of the areas of the four rectangles is the sum of I equals 1 to 4 of f of I divided by 2 times 1/2, where f of I divided by 2 is the height and 1/2 is the width. Simplify f of I divided by 2. Use the first summation formula to bring 1/2 to the front of the summation. Use the second, fifth, and sixth summation formula to simplify the summation from I equals 1 to 4 of I halves plus 1. Simplify 4 times the quantity 4 plus 1 divided by 4. Simplify 1/2 times the quantity 5 plus 4. You find that the summation is 9/2, or 4 and 5/10. Therefore, the approximate area is 4 and 5/10 units squared. Find the area of the region bounded by the graph of f of x equals 3x and the x-axis between x equals 0 and x equals 1. Use the formula a equals the limit of the sum from I equals 1 to n of f of a plus b minus a times I divided by n times b minus a divided by n as n approaches infinity. Substitute 0 in for a and 1 in for b. Simplify 0 plus 1 minus 0 times I divided by n and 1 minus 0 divided by n. Simplify f of I divided by n. Use the first summation formula to bring 1 divided by n squared to the front of the summation. Use the second and sixth summation formula to simplify the sum from I equals 1 to n of 3i. Simplify 1 divided by n squared times the quantity 3n times n plus 1 divided by 2, and simplify. Simplify 3 times the quantity n plus 1. From this form, you can see that the degree of the numerator is equal to the degree of the denominator, so the limit is the ratio of the coefficients of the highest powered terms. Therefore, the limit is 3/2. The area of the region bounded by the graph is 3½ units squared. Find the area of the region bounded by the graph of f of x equals x squared plus 2 and the x-axis between x equals 1 and x equals 3. Use the formula a equals the limit of the sum of I equals 1 to n of f of a plus b minus a times I divided by n times b minus a divided by n as n goes to infinity. Substitute 1 in for a and 3 in for b. Simplify 3 minus 1. Simplify f of 1 plus 2i divided by n. Simplify 1 plus 2i divided by n quantity squared. Simplify 1 plus 2. Use the first summation formula to bring 2 divided by n to the front of the summation. Use the second, third, fifth, and sixth summation formulas to simplify the sum from I equals 1 to n of 4 divided by n squared times I squared plus 4 divided by n times I plus 3. Simplify the fractions 4n times n plus 1 times 2n plus 1 divided by 6n squared and 4n times n plus 1 divided by 2n. Simplify 2 times the quantity n plus 1. Simplify 2n plus 3n. Multiply 2 divided by n to the quantity and simplify. Simplify n plus 1 times 2n plus 1. Simplify 4 times the quantity 2n squared plus 3n plus 1 and separate the fraction. Simplify 8n squared divided by 3n squared, 12n divided by 3n squared, and 4 divided by 3n squared. You know that as n goes to infinity, 1 divided by n goes to 0. And as n goes to infinity, 1 divided by n squared goes to 0. Substitute 0 in for 1 divided by n and 1 divided by n squared. Simplify 8/3 plus 10. The area of the region bounded by the graph is 38/3 units squared.